So in our last class, we discussed about how to read the data frame to your Colab or your Jupyter notebook. So this is how you read the data frame. Then you put the link or the path to the data. Then you check some attributes of the data, the information about the data, the shape of your data, the columns you have in your data. Then you use describe to check the statistical the description of your data. Then you check the data type, the maximum value, the minimum value, the mean. Then you can check the head to check for the first few rows in your data. The same thing for the tail to check for the last few rows in your data. Then you can do some along the column. Then you can do some down the row as well. Then there is a way you can add a new column to your data frame. Then another thing we discussed about for example, let's say you subset your data, then you need to reset the index to have regular index from 0 to the last number. Then you check for missing values in your data frame. Then how to check for the percentage as well. This is how to check for the percentage of missing values you have in your data frame. So how to drop those missing values. Then there are a lot of things you can do to your data value. You can decide to drop them. You can decide to drop the rows with the missing values. If you also see that there's a particular column with a lot of missing data, you can decide to drop the column. So this drop now is for the rows. Then you specify the axis. This one is for the column. Another thing you can do is to impute the missing values. You fill it with something. So this is just filling all the missing values with a single value which is missing. Then you can decide to fill each of the columns by, let's say, the forward fill, backward fill. Then you can fill them by their mean or the median score. So today we'll be talking about how you can filter your data. So I'm starting by importing the libraries, the normal libraries we use. You have the and the NumPy. So those are the libraries we use for data frame manipulation. So I started. So I started by importing those two libraries. So, and I don't know if anyone has problem with the data set we've been using in place. Hello? Are you with me?
Hello? Yes, we are with you.
Do you have anyone that is having a problem with the data set, like getting it from GitHub? I mean, none of us is even practicing what we've been doing. I will be calling names. Sister Hanifa.
No.
Have you tried to work on the?
I'm not actually. No, I've not. No.
Brother
Currently, I'm doing an exam in school, so very soon.
Okay. So let me just show you how to get those data. For example, this is the GitHub repository we are using for the class. This is the GitHub repository we are using for the class. Just come here. These are the repository. Then you click on the data. These are the data we've been using for the class. Then, if you remember, the first one I downloaded, this one is the data set without missing values. Then when I remove some missing values there, this is the second one. So this is the one we are working with the one without any missing value. So you click on it, then you see something like this. This is the data set. And if you want to have it on your system, you click on raw. Then you see the data here. Just press Control S, or if you're using Windows, Control S. For those people using MacBook, you can press Command S. When you press Control S, it is going to give you like you are saving the page. Like if you want to save the web page, but you are not really saving the web page, you just want to save the data set. So there will be a pop-up. Comma separated file. By default, just click save. Then after that, you can go check your download folder. Okay, you click save. Then after that, you can go and check your download folder. Another thing to download a notebook. Maybe you want to practice with the notebook we've been using here. We cannot see this is the CSV now. It's just I just downloaded it to my system. So what you can do now is, if you check your download folder, you see that you can now move it from your download folder to your working directory, or you can read it directly from your download folder. Another thing, if you want to download those notebooks, you follow the same procedure. You just click on the classes. Let's say you want to download the last class, which is the 11. Just come here, click on it. Is it taking time? So once the notebook finish loading, you just click raw like you did for the CSV. Then you click Control S to save it on your system. So what you do is, so you can see the raw file. This is the raw file. Don't worry about you might like me myself, I don't understand all this, but don't worry about it. Just click Control S on Windows, then Command S on MacBook. Since our notebook is always in .ipynb, which means IPython notebook, you make it IPYB your extension, then you change this test document to all files. You change it to all files, then you click on save. So you can now check your download folder now. You can see the download it has not downloaded yet. You can see the 11.ipynb. You can see it here. The same thing with the .csv. I cancelled the CSV file. You can see it here. I cancelled it. So I downloaded it. You will see it here as well. You'll have seen it here as well. So that's how to get your notebook or your data set from the GitHub repository. So back to our class. So this is the data. I name it DF. Then to be sure that I'm working on the right data, I check the head, df.head. So these are the things we'll be talking about today. How to filter your data, how to subset your data, how to group your data, how to do pivot table. Then we can work on date time as well. So we understand this is what we did in the last class, and we added one more column to the data frame to have the total score. So I can check the head now to be sure that my total is there. So we can all see this 407 for the total for the first student. So one thing I forgot to talk about in the last class is how to, for example, we know how to df.head get the first 5 data, first 5 rows.
Please, I have a question.
What's your question, please?
I want to know, is there a naming? I know we can name our table headers, like the columns, give it a different name, like what we want it to be. But is there a best practice for naming these column headers? Because manipulating, like going through when you're typing your codes, like changing from capital to from uppercase to lowercase in the midst of them. Like, is there a best practice for that?
It's actually, the question is subjective. There are a lot of people, they don't care about any case they're working with. But me personally, I prefer working with lowercase. So, and this is between the last dot's name. I prefer bridging the gap with an underscore. I'll put this. That's underscore name. And I will tell you why. Let me check this. Let's say I have df If I want to check for this last name column, I will do this df, then last name. I have the column. You can see it. Then I can do the same thing for intelligence. There was a mistake in my name. You can see df.intelligence. So there's a faster way to do this thing. You don't need to put these square brackets, then just put df dot, then the name of the column. Intelligence. You can see this. Then I have the same thing. I can do this same thing with total. I have the total score. But if I want to try it with last name, it won't work because there is a space between last and name. This can never work. You can see the error. So what I need to do for this is just to make sure I put them in this, then I remove the dots. But if you read this way, you put last name, then underscore, last underscore name, you'll be able to apply this on it as well, last underscore name. So this doesn't, you can let everything be in capital letter or lowercase or uppercase, it doesn't matter. But preferably for me, I like making everything lowercase. And there is a way we can do that as well. I hope I've answered the question.
Yes.
Okay. So we talk about how to check the head of the data frame. Head. Let's say the first 20. We have the first 20. Then if we just want random sample, just df.sample. Then you put in, we can see this, the first 20 we checked initially. We have from 0 to 19. Those are the index for the first 20 data points. Then just put dot sample, put 20. We can see that the selection here is random. For example, you have 19, then 16, 0. It is random selection. We can be very sure that these data points, they are good representative of entire data set. These 20 data points, they are representative of the entire 20 data set because their selection is random from different parts of the data sets. I hope we understand what I mean by that. Do we understand that?
Yes.
Yes.
So that's how to do random sampling, random selection instead of doing .edge.tail, just random selection. So the second thing we'll be talking about is how to filter our data sets. So it depends on what we want to filter. For example, we don't want to see any score lesser than 50. Just put df.query. We can just deal with the total score. df.query. Then you put it in brackets. Want total greater than 50. You know all the total scores, all of them are greater than 50. Let's say 300. Greater than 300. You can see those are the students that have total score greater than 300. That's a kind of subset. Another kind of subset is to put some conditions. df, then we put the column. Let's say the score is greater than total greater than 300. Then we want the data we want just for the female. We just put a condition and then we repeat something like this. Instead of putting total here, we put gender. And instead of greater than, we put equals to, and we put female. Python is a case-sensitive programming language. If you are putting just this, it won't work because as you can see, all of them are in uppercase. So you need to write it exactly as it is. So let's check what we have for this. I'm going to get error. So you still have the error. Then what if I put a df at the end? That's still not working. Let me do it separately. Put each one of them in parentheses, each of the conditions. Okay. Total greater than 300. Okay, let me use greater than or equals to. You can see this. Those are the people. This is exactly what we did here. Checking those total that is equals to 300, but we want to include more than one condition. For example, the first thing I said, let me delete this. Let me break it down. The first thing here is to check the data frame greater than 100, greater than 300. Then I have true, false. So I don't need this. What I need is the entire data set where the condition is true. So I need to put all these condition square bracket. Then at the back, I put the df to return a data frame where the condition is true. Then I run the code. So I have the data frame. Then I can specify another condition and df gender equals to female. Let's see if this will work. Okay. Total is greater than 300. Then close this. And df gender equals to female. Let me try it out first. This is the first stage where we have the total score greater than 300.
Can we see
And
the?
we should be able to include some more. What do you say?
I was thinking maybe we should see the true false combination of the
Oh,
conditions
for the
first.
other
Or
one, that's true.
let's see what it looks like. If it works, then we'll now put it in get the data frame and see what happens.
All right, thank you. Let's check that. We have the condition as well. We have true, false, true, false, true, false.
Okay, let's combine the conditions then before getting the data frame.
Like this, right?
Yes, let's see our conditions first.
DF total greater than 100, then DF total equals to female. Let's try and put each one of them in a parenthesis. That might be wrong.
What's happening?
It's normal to encounter something like this while writing programming, actually. DF total greater than 300 and DF equals to female. Okay, let me quickly do this. For example, let's say you want to change the gender, DF gender equals to female. You can see those. You can see that this is where we have gender as female. Then we can rename it as where we have gender equals to female. We have gender equals to female. We can rename it as female or lowercase. Whoosh. Does that work? Let's check our data frame now. Whoosh. So it is not working. I need to run the codes from the beginning where I imported the data. So I'm deleting this line now.
Female does not have ending quotes.
Yeah, I've seen it, the quotation, the closing quotation mark. Okay. You can get back to that, yeah. So the next thing, let's talk about how to group your data sets. PF does group by. Let's say we want to group by gender. We will name it gender. We name the resulting data frame as gender equals to gender.group by. Then gender.edge. We can check what we have. Give me 1 minute, please. I want to check the.
Okay.
Hello. Hello.
Yeah, we are here.
We can
I'm
hear
sorry
you.
for the delay. So for the group by objects, I grouped the data set by gender. So we can perform aggregate function on the gender data frame now. Dot aggregate. Then we can pick a particular column, let's say math. Then we'll pick aggregate function. And this should be a dictionary. Yeah. This is for the mathematics. We grouped by gender. So we have the mean score, average score for the female is 86. Then average score for male is 75. Then we can do sum as well. This is the sum of female, the odd males. This is 950. Then we have the male, 1130. So one more thing I forgot to talk about is EF dot gender. For example, let's say we want to know the number of male, the number of female we have. Then dot N, that's unique. Unique is just the unique genders we have in our data set. So the gender is in capital letter. You can see we have just male and female. Another thing we can do, we can check the number of unique values. Instead of putting unique, just put N unique. So we see the gender is uppercase. So you can see that. Another thing is value count. df dot, let's say math. No, intelligence, let's use intelligence. Dot value count. Value underscore count. This value count will tell us the number of unique values we have in that particular column, in this intelligence column. Then it will tell us the frequency of each one of them. So let's check that. We have 4.8 two times. It's normal by the order is by like descending order from the biggest to the lowest. We have 4.8 two times. That's the only one we have two times. Others they occur one time. One time. And that thing we can check. We can check for the gender as well. You see the number of male, the number of females we have in our data. We have 11 male, then 15 males, then 11 females in our data set. We can do that on, let's say, math as well. We see that in mathematics, 9 people, they have a score of 100. Then 3 people have 75, 3, 80, 85. So that's for count. We can plot this one directly into a data set. So another thing we will be talking about is Panda data frame. PD dots. Pivot table. Who knows about pivot table? It's very common in Excel, then Power BI, and I'm not sure if it is in Tableau, but I'm very sure it is in Excel and Power BI. So pivot table is under pandas as well. It's just a table that helps you group your data. So you put in the first thing you'll be dealing with is to put the values. You can see it here. The data frame, then the values, then we have the index, the column. Then you can perform aggregate function on your data. So the first thing to input into the function is data. Our data is df. Then the value we want to is, let's say total. We want to work on the total score. Then we want to group by female, by gender. So let's check this out. You can see we have total for female 389. Then for male 348, which is different from what we have here. It's different from what we have here. So there is something happening. I think the aggregate function for this by default is ag function. By default, let's check the parameters for aggregate function. This is Default is NP dot mean. That's the average. So what we need is sum. Then we put the sum there. Can see? So we have gender. Total score is 4,286. Then we have for the male, then for the female. We can put one more column in our pivot table, which is the group. This is the column. We have index, we have value, we have index. Then we need the column. We can actually change this. Let's say the total is, let's say math. Then our index is math, then gender. Then we call this, let's make gender our index. Then we have math. Then we have intelligence as our column. And the aggregate function, let's make it the default value we have mean, which is mean. So we can't make gender our index. So we switch this again. I have the total as my column. Then this is index. No, we don't want this to be. Let's go back to what we have initially. We did just the math and the gender. It's not possible to combine the mathematics column and the intelligence column. Our value will be total. Then index is gender. Index is what we want the label to be. What we want across this side. So we have the total for gender for male, then the total for female. We can put this directly into a chart. What did I just do? Okay, we can put this directly into a plot, a graph. Then dots plots. Then a bar, we use a bar plot. And equals to bar. So you can see this is the bar plot for the total score for both gender. So another thing we should talk about is how to work with datetime object. To work with data, we need a package called datetime. So you import datetime as DT. And let's try to, there is one of the dictionaries we created the other time. Is it the 10? The 9? Okay, let me check the repository. Okay, this is the student dictionary where we have the school. So we want to add a new column to the data frame. Fix. Then we convert our data to, let me call it df2. Convert it to a data frame. This is our data frame. Then I want to add a new column to the data set, the admission date. So it will be df admission date equals to, I'll put in a list of value, let's say 2022, then October, then 34. That's for one student. Then for another student, 2021, May, then 12. We have 4 students. Then for another student, let's say 2020, January, then 02. Then the third one, we have 2022 as well, December 11. And for the last student, 2021, 12, 28. So let's check what we have. df2. Then I check df2. I put 5 values, whereas I need just 4. I need to remove 1. You can see this. You can see the admission date here, but it is not properly formatted. So to do that, even if it is properly formatted, df2 dot admission date dot dt dot 2. Dot to date time. We should have date time here, date time object. Have I imported it? Import date time as dt. I have it here. Then admission date dot dt dot. Okay, let me put the proper format here. So if you check the data type now, df dot d types. We have the admission data as object data type. Not to date time. Oh, I need to specify the particular column. DT dot admission date. Then dot to DT. Okay, this is date time. And admission date. If we check the data type here, we have it as an object data type, which means the system recognizes it as just ordinary string, not actually a date time. Day is out of range, 34. So we don't our we know 30. Let me make this 14. Then we check the data type here. It is still an object data type. Then, so I've converted it to date time here now. I will now name it back. Let's see. So I renamed the admission date to the new data I have. Then I can now check the dt.type df2. You see now, here we have the admission date as object, but here we are having it as date time. With this now, if we try to extract, let me try and extract the month here without converting it first. So let's say the month df admission date dot dt dot, let's say year. If I try to do that, I'm going to get an error because it is not yet in a datetime data type. So I need to first convert it to a date time with this code. Then after that, I can now extract the year, the month, the day successfully. So let's do that here. This is after converting it to a date time. You can see we have the year 2020, 2021, 2022. Then we can name it df2 year. We make this year. Then we check what we have, df2. You can see a new column now with the year of admission. Are we following, please?
Yes.
Then we can extract the month as well. So instead of year, put month here. Then we check df2. We can see the month of admission, year of admission. Then finally, we can extract the day. And instead of dot year, it will be dot day. Then we have it. So we can see we have the day, the month, the year. So the essence of converting your date or your data type to a date time object is that by default, initially the code will be recognized as an object data type, just ordinary string. You can see the format, it looks like a date. But when we try to check the data type, it recognizes it as an object, which is like just ordinary string. But after converting it to a datetime object, after converting it to a datetime object with this, the new data type is now datetime. So with this data, once you have your data type as datetime, you can do a lot of manipulation on it. You can check. You can check the year of admission, then the month of admission, the day of admission. Even if it is in, let's say it is in. Let's try to add some other things. I want to add the exact time of admission. So to do that, we just put, let's say this person 12 o'clock, 12:45, then this person 01 13, and this person 20. The time we can have 24. Is it possible? Okay, let's say 23:59. That's 11:59. Then this person, let's say 15. Oh, that's 3 p.m. So you can see. Let me try and run from here. And we can see the daytime. Then we check the data type here. Then I'm converting it to a date time object here. So we have the date time. Then I want to extract the year. Then I've extracted the year, but we still have the time. We should be able to extract the hour as well. No. You can see the hour. You can see it. So we can name that. You can name it as hour. Then we do the same thing for minutes. So we have, for example, this is 12:45. Then why do I have 12:14 here? What's happening? This is supposed to be 3 p.m. 11:59. Do I need a comma? Oh, you have the hour, the minute, then the last one is seconds. Then 14:4, 2022, 12. This, oh, I didn't change this. This should be hour. Let me try and run it from where I created the data, the dictionary. So we can see now, this is 12:45. Then we have 12:45. This is 1:13. Then we have hour as 1, then minute as 13. The same thing for 11:59. We have 23, then 59. If you would like, we can include something for the seconds as well. But by default, it will be 0, 0, 0. It will be 0 by default. So after done with our data set, we can actually make this, we can write it to a CSV file. For example, we know all what we add initially is just student, gender, and age. But we have a more detailed data frame now. We can write the whole of this data frame to a CSV file, to an Excel file, just repeat the dots. So that's cool. We can write it to a datetime numeric, a lot of things, but we're making use of CSV because that's what we've been doing. PD dots to CSV. Oh, it will be df2 dots to CSV because we are writing df2 to a CSV file. We can write it to CSV, we can write it to clipboard, we can write it to Excel, we can write it to HTML, SQL. So we'll be writing it to CSV because that's what we are more, what we work on, mostly on. So the name will be students details .csv. Then if I try to, let me try and run this details. And by default, I don't want this. If I don't put the index column, this 0, 1, 2, 3, 4 will be there as an index. So let me do that first. It has been saved. If you check here, we see it here. This is student details.csv. Then I can read it again to check what I have. pd.read _ csv. Then I copy the student details.csv because I have it in the same directory I'm working on. So I have, this is what I was trying to avoid. I have this index, the initial index, 0, 1, 2, 3. I still have it here. So to remove it, when I'm writing to CSV, I just need to specify column index equals to false. I don't need any index. Index equals to false. So I'm rewriting it again now. Then I will check it again after doing that. So I have it now. After writing it to a CSV file, then I read it again to check what I have. So I have the new data set. This is the new Excel file I have now. I can download it and send it to people. So this is the new, what we've worked on now. This is the new data, the latest data set for the students. So I think it's good to stop here. Next time I will work on the how to subset very well, like whereby you can combine multiple conditions. For example, you want to check for females those that score above 300. So we are going to start from that in then our next class. Then next class basically gradually we'll be dealing with visualization, how to check the graphical representation of our data, the distribution of our data graphically. That will be making use of Matplotlib and Seaborn. So if you have anyone with a question. Hello.
Okay. Not really like a question, but we haven't been doing any assignments for some time.
Okay, I've been thinking about it actually, but no,
Because it helps us keep up.
I'm working on that. Very soon you will get to work on something.
Okay.
Thanks for raising that. Do you have any other person contribution or question, anything? So should we have our Saturday's class tomorrow this same time? The one we missed yesterday.
That's
No.
6 to 7.
We have this thing by 5:30.
Oh, that's true. So when should you have a makeup class for the Saturday class? The one we mixed.
We can spend more time next weekend.
Okay. All right. So you guys should have something to work on this before next class. I will work on it and send the link to the group.
All right.
All right.
Okay.
Bye-bye.
Bye.
Thank you.
You're welcome.